5,000 routes. So how do we dynamically make that happen across the whole network? Because we're talking about over 700 pipes, right? So it's impossible to have an administrator there 24/7 to actually try to add our...
Let me, Doug, you're asking the right question again. I hate it when people ask exposing questions. But, and I hope there's nobody on the development side that's going to take the following comment personally, okay? But the content locator right now is the BOR content locator, the box of rocks content locator, okay? It doesn't know a thing about BGP, it doesn't know anything about how the right way to do this is. It looks at load on machine and makes some estimates, but you know, that path may not be the right path, all those things. You're right. That's why it's a future thing. That's why right now we use Fine Splitter and ASX scripts, because it failed the QA test lab. It failed because of just what you're saying. So I don't know the right answer, but you know, as soon as we know, you'll know. Or frankly, if you've got some good ideas, you know, fill us in.
We're going to be coming out with more technical briefs. So I'm going to be working with the engineers to actually get kind of data sheets around some of the technologies underlying it, because we've gotten lots of requests like that for different pieces. We have been holding bi-weekly meetings with the sales engineers to try and keep them up to speed, but it'd be nice to get these written. David.
Understood that all the intellectual property that we own or that we've developed in this area is just getting rolled up into G2 without us really making any money off of it. So my question is, what are we doing to protect the intellectual property in the locator and the processor, and of course, Tommy's not involved in this, but in the multicast piece? Because you know, we're spending a lot of money to get this developed, and you know, Mark Cuban is just getting all the benefits. Is that accurate, or is that not accurate?
Not quite. I don't know whether John wants to comment on this. As part of the process that we've been going through over the last month of bringing things together, we have actually been sitting down with engineering and identifying what things are truly IP that would be patentable, and what is really kind of industry standard that we've just found a different way of putting together. And I don't know if you want to add.
There are, David, we looked at a lot of the claims on some of these recent patents that you've seen announced, and it's my read they will not hold up. The first time they're prosecuted, they'll fall apart. We don't have the energy for bogus patents that aren't going to stand up, unless, of course, we form kind of a portfolio view and we actually try to fill the whole landscape. So what Kirk is talking about is we currently have, I think it's 6 different abstracts for filing teed up that we're working with legal counsel on. The issue is really twofold. One is that we've discovered the agreement outstanding with Real basically says all the intellectual property we develop is theirs. You know, whatever. We didn't handle that relationship right, post-mortem.
Well, is there anything that we can do to eliminate that in the interim, so that
before we hand them anything, we can actually file for a docket number. So it's made clear that this was prior knowledge, prior to actually engaging the engineers. They have engineers working with us on site. We got to go off in a corner, write a couple of abstracts, do the filing. So I mean, the contract relationship with the corner we painted ourselves into is a problem. The other issue is that as soon as you announce for sale, the clock starts on international patent filing rights. So you know you get a very finite period of time to get awards. So the clock is ticking.
But it's I guess my assumption is correct that all of the work that we've done on Universal Locator, on the log processor, and on multicast for G2 is property of Real Networks.
Some of the stuff that's property of Real Networks was incorporated into the latest release of their server software, which was actually our fixes to the Fine Splitter technology. So it's some of the more of the front end. These 2 projects in particular were started after we found out that their technologies were not as robust as we needed, and we were having to spend a lot of time helping them do quality assurance and really giving that property back to them.
So the content locator's got intellectual property in it we're going to capture and keep, number one. Number 2, we have a different relationship with Microsoft, for example. We do not have multicast on the backbone with Windows Media Player yet. But you know what? We know how to do it, and they don't. Believe it or not, they don't. So the relationship is different there, working with Scott to make sure that we actually go and develop the fixes, the augmentations to their source code and that's our source code. We're not going to be in the business of supporting Windows Media Player servers in perpetuity, but that's a heck of a bargaining chip. We did it with Real. We can claim that, yeah, a lot of that revenue rolled right up to them, and they should thank us for it. We're not going to do the same thing with Microsoft.
Well, and I hate to draw this out, but so we should probably go back to Real now and say, on a go-forward basis, the rules are going to change around the intellectual property and the development work that we're doing for you. I mean, given what's happening in the market with Windows Media Player and everything, we just need to make a point to do that like in the next couple of weeks. Because we're doing so much work and that's contributing to their success. And I mean, given what I think all of us know about the relationship, it hasn't been the best. So I think now's the time to go back and revisit that, because this is clearly, we've made that product competitive. And we need to go and restructure that relationship.
Right. We anticipate they may not win in the end. That's why we broke it out. So, but point taken. We'll take an action to do that.
I want to go through what's different about caching within our network. So when you look at our network, it's a hierarchical network. So at the top level, we have the content that's ingressed and it's stored. When we put caching in place, we're going to have terabytes of storage in Portland. We're also going to be adding capability in Houston and New York. Then it drops down. The next level in the hierarchy is the Enron City Pop, which again is another place where we'll have lots of storage capacity for accessed content. And then the E-powered ISP. So actually the streaming server is sitting there with storage capacity right next to it to pull off of. So when the first end user goes up and we have caching in place, he asks for that stream. It'll go to the E-powered ISP. If that content hasn't been accessed, the server at the E-powered ISP will actually look upstream to the City Pop, to the storage facility at the City Pop, to see if that content's there. If the City Pop hasn't had that content accessed yet, it'll actually go back to the storage server where the content was ingressed. It goes to that cache. That cache says, yep, I've got it. I'm going to start to deliver downstream. And that downstream delivery, and this is really what's different that Inktomi is doing for us, that downstream delivery is going to be streamed as if it's a live stream. So when it hits the Enron City Pop, the City Pop is going to move that stream forward, just like it does in a live event where it's handing that forward. But now it's going to, as it's handing that request forward, it's actually going to copy that streaming file into the cache in that City Pop. So then that stream, which is looking like a live stream, it's being passed off to the E-powered ISP. The E-powered ISP delivers it just like it would a live event, but at the same time, it's storing a copy of that stream in the cache server at that E-powered ISP. So then when the next end user comes along, it makes the request from the same E-powered ISP. That E-powered ISP now has that piece of content in the cache and can deliver that request one hop away. That technology hasn't been released yet from Inktomi. We're actually working with them on the delivery of this hierarchical method of caching. There's other folks that are using Inktomi for caching of streaming content, but not in a way that you could actually use a hierarchy of storage mechanisms so that you can have different amounts of content available at different times to different areas within a network. We're working with Inktomi on the delivery of that. We should be getting code from them around the 1st of February, and in the process of implementing that throughout February and beginning of March is really when we'll be actually getting that deployment out.
How much of a buffer time remains multiple hierarchical requests?
It's going to be just like a live event. There actually isn't any additional latency built into it, and that's what's new about the actual software.
But that's what's important about our network, because other people's networks, like I can't handle live events. And other people's networks, like this live, I can't handle live events. So our network is the only one right now that can exposed and still give a high quality service for something that would have been considered on-demand content.
Right.
Though we don't push everything to the edges.
Right.
Which reduces our storage costs.
Mm-hmm. Definitely.
Dramatically. Let me just throw, this is so significant. It may not look it, but that big box, the big blue thing, the Enron City Pop, we're talking terabytes here. We are building stuff that these other guys wouldn't have a clue how to build. multiple racks of network appliance boxes just racked to the ceiling, huge investments in storage. That, let's say, the Inktomi software really comes out in a bona fide, supportable way, end of the year kind of time frame with hierarchical caching. Nobody else can afford to implement the infrastructure to actually do this. So they're flat caching. They're dead.
Kirk, is the caching technology utilized here, is it for all three Windows, Windows Player, QuickTime, and Real? What we feel that Inktomi will provide in the near future, or set for Real?
They're adding more content flavors all the time, but that we're confident that Inktomi is going to be able to cover all the formats that we want to be able to deliver.
But do we know that?
Yeah, definitely. I mean, they're already doing G2 and Media Player and adding QuickTime, so it's already out there. Yeah, and actually, I mean, SkyCache, I'm not sure whether they're delivering with Inktomi or not, but most of our competition, and we're going to be covering this tomorrow, there's actually a whole session where the folks from McKinsey that we've been working with are going to do a competitive analysis. But most people that are doing any type of streaming cache are using either Inktomi, or there's a few appliance boxes that are starting to come out that have streaming capability on them. But it's really, Inktomi is the only person that's added streaming formats to caching software.
Everybody's getting confused. There's caching, there's transportation too, There's cars, trains, everything.
Okay.
Caching is a concept. So most caching today on the internet is flat file web pages. And the really hot stuff is now some random tags. So most caching is not streaming.
Right.
People need to understand that. You hear the word caching, it's like saying it's transportation. What kind of caching are you talking about? Because a car is different than a truck, and our caching is different than just plain old web page caching.
Right. Sure.
With central storage area, we don't do anything right now.
Initially, by having only PDX as the content storage place, then that is a single point of failure. That's also why we're bringing up other locations for redundancy. As far as the latency, again, the latency is not going to be, there's not going to be a latency impact. It's going to be just like they were making a request for a live event.
It'll take a fraction of a second to complete the leg and actually open the stream back, but once the conversation started, we have committed to engineering a network to guarantee that that major priority feed from the top to the bottom happens. How do we do that? We have currently a group of people working with John Griebling's folks. This is actually a textbook distributed computing problem. This is a pretty tough problem to crack, to size a network and to actually get all the mechanisms like RSVP and MPLS and RTP and RTCP, which we're moving to all work in this environment and make sure what April just said is true, that, okay, I click on that and it's not there, well, I need it now. We are writing SLA, service level agreements, with terms and conditions in them that say, thou shalt deliver 99.9, a huge number of the streams are all going to open up and happen within 10 seconds and get there. You can only do that through modeling this. Because when April or Matt rolls in with another, geez, I got another 40 gigabytes of content, and it looks like I'm going to need to support 100,000, 200,000 simultaneous streams. Well, into the back room go the mathematicians who now work on the spreadsheets and come back and say, yes, I think we can do it, but the service levels just fell to 99.7. This is not a simple problem. So there are a lot of folks modeling this, and we are going to have to grow and learn our way into it. April raised a very key point when she spoke. We got to go find content providers and sinks of data at the edge that kind of meet our caching philosophy. We like to have stuff that stays statically cached at the edges. Somebody who's got a lot of thrashing in the cache, for those of you that are computer science type people, that could kill us in this scenario. But we're out there, we're trying to stay ahead of you all, modeling this as we release it.
So I'm going to skip through this example because we're running out of time.
Hey, Kirk, that's a quick question.
Actually, hold it for later because we're not going to be able to get through the material if we don't. With Multicast, under normal TCP/IP routing, a packet is routed from a specific source address to a destination address. This is often referred to as a unicast type of way of delivering. So it goes on a hop-by-hop method across the network. With IP multicast, what happens is the destination address is not actually assigned to a single destination. It's assigned to a group, and receivers actually sign up to that group. And I'm keeping this at like 50,000 foot level. Don't want to dive into the details, but I want to make sure that the concept gets across and how that helps us. When you look at then IP multicast enabled application, which the Real Networks G2 server software is, Windows Media Player is not currently, but G2 is, that allows you to send one copy of that packet or set of packets to a group of receivers rather than to a single receiver. So on a live event, instead of having to send 200,000 identical packets across the backbone, we send one across the backbone, and as people join in, that request down the hierarchy in the network then divides that out and delivers it so that we manage the bandwidth much better. It only forwards the packets to those networks and hosts that need to receive them. So it allows you to manage the traffic within the network much better. So how that benefits us, for a live event, it reduces the amount of traffic that we have on the backbone. So as we bring other applications on, like transport and video conferencing, a live event, a huge live event from MediaCast isn't going to tear up your video conference. This is what people run into problems with delivering internally within an enterprise network, and why enterprises are looking at multicast as they start integrating video into their things. This is also going to allow us to do larger live events because the number of transactions that we actually have to deliver from our Ingress servers is reduced. And it's going to allow us to start targeting the enterprise. We're actually in the process of working with Cisco on going out and targeting enterprise customers. Our network is multicast enabled, so we can use multicast to get that content out to the edge. What's happening right now is once it gets to the edge, then it has to be delivered individually to each request that's coming. By going in and working with Cisco, Cisco already has enterprise customers that have their networks either multicast enabled, or with a quick software change and reconfigure it on their routers, they can do multicast. So we're trying to work with them to target enterprise customers so we can actually hand off that multicast stream and allow them to manage the bandwidth within their intranet to use video technologies much more efficiently in their network. So I'm going to go into pricing. We just in the month of December changed the pricing model so that we added the flat rate pricing. The standard pricing model that we use as far as the variable monthly charge is a stepped pricing model. So for the 0 to 250, for the first 250,000 megabytes delivered, the content provider is charged 5 cents. When for the next 250,000, that second 250,000 is charged at 4 cents, and the model continues to step down. What we found were that some customers didn't have a good feel for how many megabytes they were going to consume, as well as they wanted to be able to budget what their expense on streaming was going to be. So we came up with some flat rate pricing that allows the sales folks to actually go in and engage a customer, and if the customer has a ballpark figure for how many megabytes they're going to be delivering, they can then go ahead and pick a pricing model and commit to being charged, say, $10,000 for flat usage of 250,000 megabytes. And then when they go over that set amount that they've signed up for, then they go to a fixed 4 cents a megabyte, say, in Plan 2C. In addition to the variable monthly usage-based charge, we also have standard monthly recurring charges that are based on the length of the service that they sign up for. This covers some of our networking costs, and truly, actually, on the 6 month being $10,000 a month, part of that cost is actually a barrier so that mom and pop shops that have small amounts of streaming that really isn't a core focus for us, to a certain extent it is a little bit of a cost barrier so that we're not going to be as amenable to the mom and pop shop. We really do stay focused on the high-end content provider. We also have a variable monthly storage charge. As we looked at caching, we're relieving some of the storage issues that we have. But right now, as we push content out to every streaming server we have in the network, that means that whichever pop facility we have out there that has the smallest amount of storage today, that's our weakest link in how much content we can actually have on the network and offer. As I said, caching helps us out with this so that then we can centralize the storage. The issue with pushing content out to the edge for everyone all the time is that not all that content is accessed. And so caching allows you to only push out to the edge the content that people are actually readily using. When you look at the pricing mechanism, if you draw it out and think about live webcasts versus on-demand, the driving factors are really the duration of the event, the download speed, so that they're looking at a 300K stream versus a 56K, and the number of total users that are hitting that. And I'm not going to step through this for the sense of time, but I do have an example that really shows you the difference in the amount of money we're going to make by being focused on high-end broadband content. If we make the assumption that someone's got, we sign up a content provider that's got 5 gigabytes of storage that they want to put on the network. Say they have 10 pieces of content that they're going to be airing throughout the month, and each of those pieces of content are 20 minutes long. So like with Matt's Lehman Brothers event that happened the other day, if they do that 10 times during the month and they have 5,000 people that are logging in to watch that 20 minutes, the difference in our revenues of it being a 56K stream versus a 300K stream is 4 to 5 times incremental. So as people get connected with broadband and really watch this content and have that interactive broadcast quality experience, our revenues get driven so much faster. And that's really why we want to stay focused on the people that are really delivering a broadcast business model. Customer trials, we've been working with the sales folks as far as allowing them to put customers up and trial the system. So they'll move content onto the network. We'll give them the URL so they can view that and make a decision for themselves on the quality of that experience. I just want to make a point here that, and April brought this up in her presentation, we really want to qualify the leads before giving them that trial access. Take the sale as far as you can forward before opening that up to them, because from the back-end support standpoint, the operations guys, it takes just as much time and effort and money to support those trials as it does a paying customer. So we want to keep the ops guys focused on the paying customers. I know it's a great sales model because when they see this experience, it does lead them to sign up. But just want to make sure that we get to the right step before doing that. We are going to be limiting the trials to 30 days. They'll get an email reminder after 15 days. If an extension's needed, the salespeople are going to have to go through April and Matt to actually get the extensions on those trials so that way they know exactly the status of the accounts. We're also going to be limiting it to about 30 megabytes of storage. What that amounts to is 5 minutes of video at, say, 28, 56, 100, and 300. They should be able to get a good feel at the different bit rates at that way without us running into any storage implications. Usage statistics, just real quick. These are the basics of the type of data we offer back. We're going to talk about that more in the billing presentation tomorrow. This is just general characteristics that we give back to content providers. Future features, as I mentioned, we're going to be doing content storage as we implement caching in March. We're also going to be then adding redundancy so that we don't have single points of failure within the network. So we'll be doing content storage replicated in Houston, New York. As I mentioned earlier, we're looking at additional ingress solutions. I know, especially for live events, there's been a lot of requests for ISDN or satellite. As I mentioned and John talked about, we're actually looking at events as potentially a separate area for a specific product manager so that we can either outsource that but really have a set process, and we will be enabling these as ingress options as we move forward. Windows Media Player, John touched on this. Microsoft actually doesn't offer multicast, so we know how to do this. We're actually going to be working to enable multicast using Windows Media Player. So that will be a feature as we start doing live events in Media Player format. Security, we have a network security audit underway. I know especially on the financial services area, security is a huge issue. I mean, the type of data that Lehman Brothers is talking about, if it gets out to someone else, is a huge financial risk. So we're doing a security audit to be able to identify those areas. We're also putting in place OS level security so that there cannot be breaches at the edge. And as we move forward beyond March, we're actually going to look at technologies that allow you to encode the stream and actually have the stream itself protected beyond just the content that's sitting within the network and the network level. Satellite. I mentioned with the egress, we're doing the beta to our POPs right now. Talked about the delays a little bit. We'll be releasing this to the ISP POPs. We're hoping March, if not earlier. The ingress on satellite, because we're starting to look at events separately, there's kind of two things. We're looking at whether we can use a partner to take care of this piece for us, as well as operations has been looking at this. And because we want to extend our reach, we've moved this back down on their plate. So we've got ops focused on really getting the number of simultaneous streams up and moving quicker than we have them focused on satellite ingress at this point.
Let me just throw a couple of things in, make you all feel more confident as you get ready to go on to lunch. This is, believe it or not, an old business plan. Okay, there's some people now that I have on board and that are working with me who have done this before. Believe it or not, in the early 90s, there was a group, the first ever cash-positive, profitable, multicast IP video company. It was a group at NBC that I started. Scott Yeager worked with us. He was a carrier on that. And we bought roof rights for some 200-some-odd ISPs. We were in every major financial institution in New York, London, Paris, San Francisco, streaming 5 different channels of IP multicast before the time was right. So we know how to do this. We know how to prioritize it. We know how to... When I gave them, when Microsoft bought my business out of NBC, I gave them a working copy of MPlayer that I and 6 other people wrote that supported multicast. They didn't know how it worked, and they deleted all that code. Okay? So we're going to go help them again. We're going to go help them figure this out again, and we're going to run a hell of a lot of dishes out. And you've probably seen some of the early work there. It's up and working. We got multicast working over a satellite link. So, I mean, we're making progress. We can't give you everything today, but I just want to fill you with a little bit of confidence. More questions, but I think we know what we're doing.
No questions.
So, what's coming next? As I mentioned earlier, one of the things we want to do, and it's been requested from the technical folks, is actually writing up technical briefs around some of these technologies. So these will be short technical papers. that'll help you go in and work with the content providers, the technical folks at the content providers, to make them feel warm and fuzzy that we really know what we're doing, and we are doing this in a much better way than anybody else is doing. Call to action, sell what we have today. We got a great solution here. We got large number of stream capacity out there. The network is delivering on the events. Get out and sell it the way that we have it already. That's what our competitors are doing. Our competitors are getting mind share because they're doing little things. They're not trying to solve world hunger. They're taking it one step at a time. We need to make sure that we're doing that with what we have today. So go out there, as I mentioned with the trials, qualify those leads, really make sure that the trial is suited for them. And lastly, from a product perspective, start looking at QuickTime as content deals and involve me, because I am going to be looking for some beta customers. I know we have Den, who is already going to be a beta customer as we bring up QuickTime, but if you have other folks that are very QuickTime centric, let me know as we go forward. Sorry we ran out of time on the questions. Murat's got the hook pulling me off, but I will be around, so just grab me.